Welcome. So in these presentations, I am going to discuss the topic on moment of inertia. And this was prepared by myself, Dr. S. Ilangovan, and my colleague N. Mukram, working as a faculty member in Department of Production Engineering, KG College of Technology, Coimbatore. And this presentation is prepared under the Creative Commons license, so anybody can use for their uh, presentation. So let us come on to discuss about the moment of inertia. So moment of inertia of an object is a measure of its resistance to change in rotation or the capacity of cross section to resist bending. Example, if you take the two wheels which having a smaller size and a larger size, so the larger wheel which requires very difficult to start or stop to make the rotations because the larger wheel need a larger moment of inertia. So the application of the moment of inertia can be used in many places, like locating the resultant of hydrostatic forces on a submerged bodies like submarines, and calculating the stresses in the beams to resist the bending of the beams. And the mass moment of inertia for the solid can be used to study the rotation motion of the objects. And if you look at this figure, this can be demonstrated as what is meant by moment of inertia. So if you take a cuboid of same size, so the centroid is located in the point C. So the one towel is passing through the point centroid, uh, centroid of this center of gravity of the component, and the other flat, which is the towel, is located somewhat away from the centroid. So if we compare these first figures, the black is easiest to rotate about the centroid because the moment of inertia required to rotate this component is very minimum. Compared to the second flag, the black is harder to rotate because the dwell point is somewhat away from the centroid. So this can be easily useful to create or understand the concept of moment of inertia. So if you define the moment of inertia, it is the product of elemental area and the square of the perpendicular distance between the centroid of area and the axis of the reference. This is the moment of inertia about the referential axis. It is also called as the second moment of inertia because the first moment of elemental area is dA into y and dA into x, and if it is again multiplied by the distance, we get the second moment of elemental area as dAy square and dAx square. So mathematically it represents the Ixx equal to integral dA into y square and Iyy is equal to integral dA into x square. So with respect to this y distance, we can measure the second moment of inertia. So the moment of inertia can be measured in different methods. The common method is called as integration method. The other method is perpendicular axis theorem and parallel axis theorem. So coming to the polar moment of inertia, perpendicular axis theorem, the moment of inertia of an area about an axis perpendicular to the plane of the area is called polar moment of inertia. Generally, it is denoted by a symbol I suffix xx or j or some books which has been represented I suffix b, or it can be defined as the moment of inertia of an area about an axis perpendicular to its plane, that is polar moment of inertia at any point O is equal to the sum of the moment of inertia about any two mutually perpendicular axes through the same point O and lying in the plane of area. So mathematically, if you want to calculate, so this is the small elemental area which has been considered with the sides of dx and dy, and this small elemental area is located somewhat r distance from the origin O. So if you calculate this I, the moment of inertia of an area about an axis perpendicular to the plane of area is called polar moment of inertia, and it is denoted by a symbol I z z. So if you write these equations, I z is equal to integral r square, the perpendicular distance and the elemental area. So if you substitute based on the Pythagoras theorem, the r can be written as x square plus y square. So if you substitute these integral equations, I z is equal to integral x square plus y square into dA. So if you divide this equation, so this is the integral x square into dA plus integral y square into dA. The x square can be counted as a moment of inertia about x-axis, and the Iyy can be represented as the moment of inertia about y-axis. So the total equation can be written as I z is equal to Ixx plus Iyy. Similarly, the moment of inertia can be also calculated by using the parallel axis theorem. So the definition of the parallel axis theorem is moment of inertia about any axis in the plane of area is equal to the sum of moment of inertia about parallel centroidal axis and the product of area and square of distance between the two parallel axes. Mathematically, if you want to represent the ix equal to ix dash plus dy square into a. So if you want to calculate this, so this slide is having the calculation of the moment of inertia based on the parallel axis theorem. So in this irregular figures, we have considered the area dA, and this elemental area is located at a distance of y from the x-axis. So calculate the moment of inertia about x-axis for a distance for the area as shown in this figure. Ixx is equal to integral y square into dA. So the y square can be written as y dash and dy. Y dash is the distance, centroidal distance between the area and the centroidal axis, and dy is the distance between the centroid point and the x-axis. So if you substitute y is equal to y dash plus dy, so the ixx become integral dx dy plus y dash square into dA. So if you expand these equations, so it will become this form. So after simplifying these equations, the final equation can be written as ix equal to d square y dA plus 2 dy integral y dash into dA plus integral y dash square into dA. So because this second term can be cancelled because in the first moment of area about centroidal axis is 0. So the final equation can be written as ix equal to dy square a plus integral y square into dA. So this can be written as ix is equal to ix dash plus dy square into a. So this is called as a parallel axis theorem. So the important disadvantage of the parallel axis theorem is which cannot be used for any two parallel axes. So among these two axes, one of the axes must be the centroidal axis. Next we will move on to the concept called as a radius of gyration. So the radius of gyration is defined as a perpendicular distance at which the whole area may be assumed to be concentrated, yielding the same second moment of area about the axis under consideration. So if you look at this figure, so the mathematically it can be represented as Iyy is equal to A into Kyy square and Ixx equal to A into Kxx square. So if you the distance between the x or y axis and the elemental area is defined as Kyy and Kxx respectively. So if you want to calculate the moment of area radius of gyration about y axis, so Kyy is equal to square root of Iyy divided by area. Similarly, the radius of gyration about x-axis is defined as kxx is equal to square root of ixx divided by area, where the kxx and kyy are called the radius of gyration. Thank you.